Let's explore the relationship between eating soluble fibre and preventing type 2 diabetes. By unpacking some of the key questions that concern the impact that consuming fibre has on the development and prevention of type 2 diabetes, we can begin to understand the relationship between diet and disease. We should start with the biggest foundational question. What is fibre? When we first think of fibre, what comes to mind is often the idea of copious amounts of fruits and vegetables, relieving constipation and possibly helping us to poop. While fibre definitely plays an important role in digestion and promoting regular bowel movements, its role in the body extends far beyond this. So let's consider what soluble fibre actually is. Where does it come from? What does it do? And how is it supposed to prevent a disease? We can begin with where fibre is sourced from. It comes from plant-based foods, in their whole or minimally processed state. This includes all fruit, vegetables, nuts, seeds, legumes, and whole grains. Soluble fibre compared to insoluble fibre is a digestible form of cellulose that our body breaks down. It's broken down by microbiota that live in the GI tract. Trillions of different bacteria live in the gut and GI tract, and their purpose is breaking down fibre and producing health-promoting compounds such as short-chain fatty acids, which we can explore later as we unpack how type 2 diabetes can be prevented. The structure of soluble fibre also makes it water-soluble, so it's digestible by the gut microbiota that live in the GI tract. Along with being broken down by microbiota, soluble fibre also has the function of increasing bulk consumption of food without greatly increasing caloric intake because it's naturally lower in calories than most processed low-fibre foods. Fibre is also one of the body's mechanisms to regulate blood cholesterol, and it does this by binding to bile released by the liver, which binds to cholesterol and the soluble dietary fibre in the small intestine. This prevents cholesterol from entering the bloodstream through reabsorption, and instead encourages the cholesterol bound to fibre to be excreted, which ultimately lowers blood cholesterol levels. In addition to regulating blood cholesterol, fibre also plays an important part in regulating blood glucose. And it does this by slowing down the passage of food through the digestive system, which gives digestive hormones more time to break down foods and produce short-chain fatty acids. It also allows the soluble fibre to break down with water and prevent carbohydrates from being absorbed too quickly by the small intestine, where they would be quickly transported into the bloodstream, leading to a spike in blood glucose levels. So, now that we've understood what soluble fibre is and its functions in the body, let's start to explore what type 2 diabetes is, so that we can understand what role soluble fibre may play in preventing the pathogenesis of the disease. So let's put out the question, what is type 2 diabetes? Type 2 diabetes is a disease where blood glucose levels rise, causing a state of hyperglycemia, due to cells becoming unresponsive to insulin. The disease begins with increased insulin resistance, known as hyperinsulinemia, where individuals continue to consume foods that create a spike in blood glucose levels, which challenges the ability of cells to respond to insulin and lower blood glucose accordingly. Pancreatic beta cell compensation is what is occurring as the cells begin to become unresponsive to insulin, which causes more insulin to be released. As this continues, beta cell compensation eventually progresses to beta cell dysfunction and failure, which is the complete inability to regulate blood glucose levels. This beta cell dysfunction is what predisposes the pathogenesis of normal functioning pancreatic beta cells to complete beta cell failure, which is type 2 diabetes. These two predispositions, alongside overnutrition and a lack of physical activity, initiate the transition to impaired glucose tolerance and beta cell dysfunction, which is known as the prediabetes or insulin-resistant stage in the pathogenesis of type 2 diabetes, and over time progresses to complete beta cell failure. So now that we've understood what type 2 diabetes is and how it develops in response to increased insulin resistance and overnutrition, we can begin to unpack what the genetic component of the disease is. Research beginning in the 1950s has attempted to pinpoint specific genes that predispose individuals to developing type 2 diabetes. And although it's been challenging to identify specific genetic codes, geneticists have confirmed that the genetic component of type 2 diabetes plays a key role in the pathogenesis of the disease, as some people are more susceptible to developing type 2 diabetes even with the same environmental exposures as other individuals that don't end up developing the disease. The specific genetic variants that lead to inherited risk of developing type 2 diabetes show that the lifetime risk of developing type 2 as a first-degree relative of individuals already diagnosed with the disease is 3 times higher than individuals without any family history. Genetic research has concluded that minor mutations in the following genes, in combination with exposure to environmental risk factors, is what ultimately leads to the development of type 2 diabetes. With this understanding of what soluble fiber is, what type 2 diabetes is, and how genetic factors can predispose individuals to developing the disease, let's begin to unpack the role of soluble fiber in combating the genetic predispositions and lifestyle factors that lead to type 2 diabetes. Research suggests that fiber plays a role in combating the development of type 2 diabetes by delaying the absorption of carbohydrates and gastric emptying, which leads to lower postprandial blood glucose and insulin levels. Soluble fiber, when fermented by gut bacteria in the large intestine and colon, produces short-chain fatty acids, which can increase the secretion of incretins, the gut hormones released from enteroendocrine cells, which stimulate insulin secretion from beta cells and help lower blood glucose levels. The digestion of soluble fiber in the large intestine to produce short-chain fatty acids such as acetic acid can also play an important role in decreasing appetite, which may help to regulate blood glucose levels by decreasing food consumption and caloric intake. Let's take a further look at the evidence to suggest that soluble fiber has a significant role in preventing the development of type 2 diabetes. Today we'll be unpacking 3 primary studies that have evidence to suggest soluble fiber intake can reduce the risk of type 2 diabetes. It's important to consider the context of each study and how factors such as study design and methodology can impact the findings before making conclusions about how soluble fiber can be used as a nutritional intervention against genetic susceptibility to type 2 diabetes. First, we will unpack a study conducted by Mallon and colleagues in 2018, which employed a double-blind, randomized, controlled crossover trial that measured insulin resistance and glucose metabolism and compared postprandial glucose tolerance and peripheral insulin sensitivity between one group consuming a refined grain diet and another group consuming a whole grain diet, which is inherently higher in soluble fiber. Mallon and colleagues found that whole grains decreased diabetes risk by decreasing postprandial blood glucose and insulin resistance to enhance metabolic flexibility, which means fasting carbohydrate oxidation increases, so more glucose was oxidized to produce ATP, which in turn lowered blood glucose levels, in comparison to the control. Specifically, they found that whole grain consumption reduced peripheral insulin resistance by approximately 18%, compared with a 2% rise following refined grain intake. It's important to note that these effects were independent of fat loss, which suggests that glycemic control can actually be improved by dietary intervention beyond simply focusing on reducing body weight and body fat. The use of a double-blind, randomized controlled crossover trial presents many methodological strengths that improve the reliability and validity of findings. One particular strength of the study is that all participants served as their own controls since it was a crossover study, so this strengthens the clinical applications of the findings. However, one of the key limitations, alongside a small sample size, is that the majority of the participants were female, so it's not possible to determine if sex differences in glycemic responsiveness to whole grain intake were actually responsible for the positive results associated with a whole grain diet. In addition, the study did not specifically test the effect of whole grains in people with type 2 diabetes, since 5 of the participants were diagnosed with pre-diabetes and only 3 had type 2 diabetes already. This lack of statistical significance between groups, therefore, could be related to a relative normal glucose metabolism in these obese individuals. Our second study, conducted by Kimura and colleagues in 2021, is a prospective cohort study investigating the influence of dietary fiber intake on incidence of type 2 diabetes in a Japanese population that was followed up for 14 years and measured glucose tolerance status against fiber intake. This study found that participants in the highest percentage of dietary fiber intake had a 0.53-fold lower risk of developing diabetes than those consuming the lowest amount of fiber. Evaluation of this study presents a number of key strengths, such as the use of a prospective population-based study design with a long follow-up period and high rates of participation. However, one of the key limitations that should be addressed is that dietary fiber is considered a foundational part of a healthy diet and potentially serves as a guide for high quality of the entire meal, as well as favorable eating habits and pattern that play a confounding role in diabetes prevention, separate from the role of dietary fiber. This consideration is important as it doesn't exclude the potential benefits of eating a diet high in soluble fiber, but it highlights that there are other health-promoting behaviours that also play a role in preventing type 2 diabetes. Finally, an animal study by Song and colleagues in 2000 investigating the effects of soluble dietary fiber intake on insulin sensitivity in stroke-prone rats fed a high-calorie diet found that fasting blood glucose levels were significantly reduced despite there being no difference in insulin secretion. They also found increased skeletal muscle GLUT4 transported in the plasma membrane, which suggests that soluble fiber increases blood glucose disposal by increasing GLUT4. Although the findings from this study support the notion that dietary fiber improves the ability to lower blood glucose levels without the secretion of more insulin, transferability of these findings from animals to humans must be made with caution. This is especially because the physiology of animals differs to humans, which decreases the validity of the findings. However, applying the findings from animal research with studies conducted on humans contributes to a larger body of work that suggests that soluble fiber consumption does actually play a role in preventing type 2 diabetes. So the biggest question now is, what do we do with this information, and how can we use soluble fiber as a nutritional intervention against genetic susceptibility to type 2 diabetes? The evidence from all of these studies, alongside our understanding of genetic predispositions of type 2 diabetes, gives a solid foundation for recommending dietary patterns that can reduce the risk of developing type 2 diabetes. An eating pattern that focuses on consuming soluble fiber from whole plant food sources and eating minimally processed foods should be a priority for reducing the risk of type 2 diabetes. The current recommendation is for all general population, especially those with a known family history of type 2 diabetes, to increase consumption of soluble fiber as tolerable, to improve postprandial glucose tolerance and peripheral insulin sensitivity, which is important to slow down or even prevent the pathogenesis of type 2 diabetes. The current recommendation in the latest dietary guidelines for Americans suggests consuming at least 25 grams of fiber daily for females and 28 grams for males aged older than 30. Some key food groups to focus on include whole grain foods, fruits, vegetables, beans, peas and legumes, nuts and seeds, and choosing these whole food sources over refined foods where possible. So the biggest takeaway is to continue to prioritize eating soluble fiber to reduce the risk of type 2 diabetes despite any genetic predisposition or family history.